Okay, so here's the video for section 9.6, dilations. To be honest, we've really done dilations already. Whenever I did it back in chapter 8, I made sure I didn't really just skim through it. Or sorry, chapter 7, I made sure I hit it the way it needs to be hit then. So this will be a quick video as much as I can make it quick. Let's see here, scroll over. So I've already done dilations earlier and called them similarity transformations. Now we're going to do all this stuff kind of again. Excuse me. So when we defined dilations back in the day, we defined it as basically you took a point and you ran a ray through all of the vertices, or really technically all the points, but we did like a triangle, we did all the vertices of it. And if I wanted to make it bigger, I would go like, let's say this is from C to P 4 away. If I want to make it 2.5 times as big, which is what they wanted to do, you took 4, you multiply it by 2.5, which is 10, and you go now 10 away from C to P prime. And what happens is if you go 2.5 times away from that point from the original one, it's 2.5 times as big. If I'd wanted to make it smaller, I would do less than 1. So if I wanted to make it like half, I would multiply 4 by a half and get 2, and point P prime would go somewhere like right here. And it'd be closer to point C, and it'd be half as big. So here's just another example of that. The last one was an enlargement because the scale factor is 2.5, so it's 2.5 times as big. Now this one, the scale factor is only a half. So what we do is we take all the points A, B, and C, draw rays through all three of them, and then the distances from A to D to A, multiply by half, put A prime there. From D to B, multiply that by a half, put B prime there. D to C, multiply the distance by a half, put C prime there, and you get A prime, B prime, C prime. It's half as big as this triangle. Okay. So here's our first example. There are four dilations here. Got the rays running through. The question is which one is 1/3 with the scale factor. Okay, so if I can look a little closer at this, and this is why I wanted to do it because I wanted to show you measuring it. If I want 1/3 of the length, okay, I got to figure out a distance. So I'm just to make it easy, I'm going to talk about from C to L. And on all of these, I measured this ahead of time. The best measurement is from C to L. It's about 5.5 centimeters. So CL is 5.5 centimeters. So what I want is I want a length, I want CL prime to be 1/3 of the length of 5. Oh, sorry, I got this out of frame. Of 5.5. So I'll get my calculator out. I'll do 5.5 divided by 3. Which is like 1.8, so almost 2 centimeters. Okay. So let's see here. Let's take a look. So from L prime to C, I need to be around 1.8 centimeters. Okay. Well, let's see. This is from L prime to C. It's like 3.5 centimeters right there. So it can't be A. It's too big. Let's look at C. Let's look at C since it's just right below it. C from L to C is like 1.3. Okay, so it's less than 1.5. So 1.3 centimeters. B prime, if I look at that one is about 2 or so. It's like 2 or 2.1. Let's call it 2. And then out here, this guy is away from it, but it's on the, sorry, D though, is away from it and on the opposite side. Okay, so D instantly can't count. So this guy here is like 3.5 centimeters, way too big. Okay, so it really comes down to B or C, and if this is about 2 and this is about 1.3, the closer to 1.8 is B. So this example, it isn't really accurate 100%, but it's the closest of the closer of the two. So this really should be more like 1.8 centimeters, but really 2 is the best we got because 1.3 is a little too small. Okay. All right, puppets. This next example is just an application problem, just to kind of give a bit of an application to it. So suppose you have a similar situation to the puppet and light source, with the puppet and the light source. This is actually a previous problem the book did. The distance between the light source L and the puppet P is 30 inches. So from here to here it's 30 inches. The question is, you want to make that puppet 54 inches tall. Well, if it's 6 inches tall to begin with, how far away from the screen would you have to place the puppet to make it that big? Okay, so let's look at that problem. All right, so here we go. We got our puppet. It's 6 inches tall. All right. Now, it's 30 inches away, though. So the distance of the puppet, distance over the puppet should be the same as the distance to the wall. Okay. So I have a 6-inch puppet right now, and it's 30 inches away from the projector or the light source. The question is, how far away should the puppet be if I want to make it 54 inches tall? That's really what we have here, just a nice proportion. So 30 over 6 equals x over 54. So I can reduce this to 5 over 1. 1 times x is going to be x. So we really just need to do 5 times 54, which is 5 times 54, 270. Now the answer is 270. And that might make you pause for a second and go, wait a second, how in the world, that's not one of the 4 answers here. But here's the thing. The question is not how far should the puppet be from the, how far should it be from the light source, which the light source to the wall, that is 270. The question is, how far should the puppet be from the screen? Well, he's already 30 inches, or she, I guess it is a girl. Puppet looks like it's a dancer. That needs to be then 240 inches. Okay. So that's a tough question. So again, originally we set up the fact that it's 30 inches away and it's 6 inches tall. The question is, how far would it be away if they're 54 inches tall? Well, it would be 270 inches away from the light source, but the real question is, how far would it be from the screen? Well, it'd only be then 240 inches, not 240 degrees. Okay. All right then. Okay, so dilations in the coordinate plane. This is nice and easy. It's the formula for dilations. Now, the key to this is we're talking about being away from the origin, first of all. So, to find the coordinates of an image after a dilation centered at the origin, multiply the x and y coordinates of each point of the pre-image by the scale factor of the dilation, which is k. So, in this example here, and again, the key to this is, I can't stress this enough, we're talking about being from the origin. If you're not from the origin, it causes a whole bunch of set of problems, and we're not going to cover that in high school geometry. But point P is 2, 3. The center is at 0, 0. I want this to be the scale factor of 2. I want to dilate it by a measure of 2, which means I'm going to double its size. Well, in order to do that, just multiply both the x and y values by 2. So 2 times 2 is 4, 3 times 2 is 6. But again, that only doubles it from the origin. That's the big key to remember there. So here's another quick example. I've got originally this guy here, this LKMJ. Sorry, it'd be LKJM if I said it that way. And I want it to be 2.5 times as big. 2.5 times as big. So what I have to do is multiply all the x and y values by 2.5 over here. So negative 2 times 2.5, 4 times 2.5, and so on. And you can see in the end what I end up getting is LK was 2. Well, 2.5 times 2 is 5, and L prime K prime is 5 for length. So again, all you have to do is just multiply that x and y value by the scale factor, and that gives you your your lengths. Okay, so here's the example. Which one of these three, or maybe not none of them at all, but not the none of them at all. But which one of these three is a dilation of a scale factor of 2 for A, B, C? Okay, so A is at negative 1, 1. Okay. B is at 2, negative 2. C is at negative 1, negative 2. So in order to get a dilation of 2, multiply all the x and y's by 2. Because again, we're going from the origin. Okay. So A prime will be negative 2, 2. Sorry, not double prime. I'm not doing that. B prime will be at 4, negative 4. C prime will be at negative 2, negative 4. So we're looking for the one of these three that has those coordinates. So let's see. A should be at negative 2, 2. Or sorry, A prime should be at negative 2, 2. Well, here's negative 2, 2 for B and for A, but not for C. B prime should be at 4, negative 4. So it should be over 4, down 4. There's A, has that. But B is over 3, down 3, so not B. So there was the answer, A. And just for good measure, if you look at C prime, it's at negative 2, negative 4. That one works. Okay. So again, all I have to do is just multiply all the x and y's by 2.